Hi, welcome to my cozy math journey. Today, we're exploring rational inequalities, one of the most magical topics in algebra. Because values change behavior at certain points, almost like a hidden gate opening. What is rational inequality? A rational inequality is an inequality that involves a rational expression, which is a fraction that contains variables in the numerator, denominator, or both. Look, there's our cute little fuzzy friend Totoro. He's here to guide us through a beautiful journey, one filled with wonder, discovery, and a touch of math magic. Let's follow him as we explore today's topic together. Okay, now where could he be? Ah, there he is. Now, let's go to the next slide. What makes it different? In rational inequalities, the denominator cannot be zero because division by zero is undefined. This means there are certain values that the variable is not allowed to take, and these values affect the solution. What is the goal? The goal is to determine where the rational expression is positive or negative, or whether it is greater than, less than, or equal to zero, depending on the inequality sign. Why is it important? Rational inequalities help us understand how values behave when they cause changes in a fraction. They are useful in real-life situations involving rates, proportions, limits, and more. Go ahead and grab your little notebook. We'll take this journey together, nice and easy. Don't worry, I'll be right here to guide you through every step. Are you ready to begin, my friend? Let's curl up with our thoughts and solve this together. Our first problem is x minus 2 over x plus 1 is less than 0. The first step is finding the critical point, which is the numerator x minus 2 equals 0 turns into x equals 2, and in denominator x plus 1 equals 0 turns into x equals negative 1. Remember, if our inequality symbol is less than and greater than, we only use parentheses for the whole interval notation. It's exclusive and it's not shaded, which means it's an open circle on a number line indicating that the endpoint is not part of the solution. And if our inequality symbol is greater than or equal to, or less than or equal to, we use brackets for our numerator and parentheses only for the denominator. It's inclusive and its circle is shaded, which indicates that the endpoint is part of the solution. Since our symbol is less than 0, we only use parentheses for the whole interval notation. X equals 2 and x equals negative 1 is an open circle. Our interval notation is negative infinity and negative 1, negative 1 and 2, 2 and infinity. Now the next step that we are going to do is test the sign on each interval. And the first interval we are going to use is negative infinity and negative 1. Choose a number between negative infinity and negative 1. That gives us negative 2. So now we use negative 2 as our test point. Negative 2 minus 2 over negative 2 plus 1 gives us negative 4 over negative 1. And negative 4 over negative 1 gives us a positive 4. 4 is not less than 0. For negative 1 and 2, we will use 0. 0 minus 2 over 0 plus 1 is negative 2 over positive 1. and then negative 2 over 1 gives us negative 2. The answer negative 2 is less than 0. For 2 and infinity, we will use 3. 3 minus 2 over 3 plus 1 is 1 over 4. 1 over 4 is greater than 0, so this is not part of the solution. Negative infinity and negative 1, 2 and infinity is false. Negative 1 and 2 is true. Negative 1 and 2 is our universal set. Our second example is 3x minus 5 over x plus 2 is less than or equal to 1. To solve the inequality, first move all terms to one side to get a 0 on the other side. Then you find a common denominator and combine the fractions. The common denominator is x plus 2. Then simplify the numerator and you get 2x minus 7. So now that we have the simplified form, we will now move to find the critical points. For the numerator 2x minus 7 equals 0, divide 2x equals 7 by 2, and you will get 7 over 2 or 3.5. And for the denominator x plus 2 equals 0, it will become x equals negative 2. Since our inequality symbol is less than or equal to, our numerator 7 over 2 will be inclusive and the denominator negative 2 will be exclusive. The interval notation is negative infinity and negative 2, negative 2 and 7 over 2, 7 over 2 and infinity. For negative infinity and negative 2, we will use negative 3. Use the simplified form 2x minus 7 over x plus 2 is less than or equal to 0. 2 times negative 3 minus 7 over negative 3 plus 2 gives us negative 13 over negative 1. Negative 13 over negative 1 gives us a positive 13. 13 is not less than or equal to 0, so this is not part of the solution. For negative 2 and 7 over 2, we will use 0. 2 times 0 minus 7 over 0 plus 2 gives us negative 7 over 2. The answer negative 7 over 2 is less than 0, so this is part of the solution. For 7 over 2 and infinity, we will use 4, because 7 over 2 is 3.5. 2 times 4 minus 7 over 4 plus 2 gives us 1 over 6. 1 over 6 is not less than or equal to 0, so this is not part of the solution. Negative infinity and negative 2, 7 over 2 and infinity is false. Negative 2 and 7 over 2 is true, and that's our universal set. Third example is 2x plus 1 over x minus 3 is greater than or equal to 0. The critical point for our numerator 2x plus 1 equals 0 is negative 1/2 or negative 0.5. And for the denominator x minus 3 equals 0 is going to be x equals positive 3. For our numerator x equals negative 1/2, it's going to be inclusive. And for the denominator x equals positive 3, it's going to be exclusive. The interval notation is negative infinity and negative 1/2, negative 1/2 and 3, 3 and infinity. For negative infinity and negative 1/2, we will use negative 1 because negative 1/2 is negative 0.5. 2 times negative 1 plus 1 over negative 1 minus 3 is negative 1 over negative 4. Negative 1 and negative 4 becomes positive 1 over positive 4. 1 over 4 is greater than 0, so this is part of the solution. For negative 1/2 and 3, we will use 0. 2 times 0 plus 1 over 0 minus 3 is 1 over negative 3. Negative 1 over 3 is not greater than or equal to 0, so this is not part of the solution. For 3 and infinity, we will use 4. 2 times 4 plus 1 over 4 minus 3 is 9 over 1. 9 over 1 is going to be 9. 9 is greater than 0, so this is part of the solution. Negative 1 over 2 and 3 is false. And negative infinity and negative 1/2, 3 and infinity is true. Negative infinity and negative 1/2, 3 and infinity is the universal set. If this feels a bit confusing, that's okay. Rational inequalities take practice, and I'll walk you through more examples so you feel confident. Fourth example is 5x plus 2 over x minus 2 is greater than or equal to 0. The numerator 5x plus 2 equals 0 is going to be negative 2 over 5 or negative 0.4. And for the denominator x minus 2 equals 0 is going to be x equals positive 2. The numerator negative 2 over 5 is the exclusive, and for the denominator x equals 2 is the exclusive. The interval notation is negative infinity and negative 2 over 5, negative 2 over 5 and 2, 2 and infinity. For negative infinity and negative 2 over 5, we will use negative 1. 5 times negative 1 plus 2 over negative 1 minus 2 is going to be negative 3 over negative 3. Negative 3 over negative 3 becomes positive 1. The answer 1 is greater than 0, so this is part of the solution. For negative 2 over 5 and 2, we will use 0. 5 times 0 plus 2 over 0 minus 2 is going to be 2 over negative 2. 2 over negative 2 is going to be negative 1. Negative 1 is not greater than or equal to 0, so this is not part of the solution. For 2 and infinity, we will use 3. 5 times 3 plus 2 over 3 minus 2 is going to be 17 over 1. 17 over 1 is 17. 17 is greater than 0, so this is part of the solution. So, negative 2 over 5 and 2 is false. And negative infinity and negative 2 over 5, 2 and infinity is true. So, negative infinity and negative 2 over 5, 2 and infinity is our universal set. Our last example is x plus 4 over x squared plus x minus 6 is greater than or equal to 0. To find the critical point of the denominator x squared plus x minus 6, we should factor it into x plus 3 and x minus 2. Now, for the critical point of the numerator x plus 4 equals 0 is going to be x equals negative 4. And for the denominator x plus 3 and x minus 2 equals 0 is going to be x equals negative 3 and x equals positive 2. For the numerator's critical point, x equals negative 4 is going to be inclusive, and for the denominator's critical points, x equals -3 and x equals +2 is going to be exclusive. The interval notation is -infinity and -4, -4 and -3, -3 and 2, 2 and infinity. For -infinity and -4, we will use -5. We will use the simplified form x plus 4 over x plus 3 and x minus 2. -5 plus 4 over -5 plus 3 times -5 minus 2 is going to be -1 over -2 times -7. -1 over -2 times -7 is going to be -1 over 14. -1 over 14 is not greater than or equal to 0, so this is not part of the solution. For -4 and -3, we will use -3.5. -3.5 plus 4 over -3.5 plus 3 times -3.5 minus 2 is going to be 0.5 over -0.5 times -5.5. 0.5 over -0.5 times -5.5 is going to be 0.5 over 2.75. 0.5 over 2.75 is greater than 0, so this is part of the solution. For -3 and 2, we will use 0. 0 plus 4 over 0 plus 3 times 0 minus 2 is going to be 4 over 3 times -2. Then 4 over 3 times -2 is 4 over -6. Then 4 over -6 is going to be -2 over 3. -2 over 3 is not greater than or equal to 0, so this is not part of the solution. For 2 and infinity, we will use 3. 3 plus 4 over 3 plus 3 times 3 minus 2 is going to be 7 over 6 times 1. Then 7 over 6 times 1 is going to be 7 over 6. Since 7 over 6 is greater than 0, this is part of the solution. -infinity and -4 and -3 and 2 are false. -4 and -3 and 2 and infinity are true. So, -4 and -3 and 2 and infinity are the universal sets. You can even pause or rewind the video anytime. Learn at your own pace. Great job today! Rational inequalities might look scary, but once you see the pattern, it flows naturally like water in a Ghibli river. You're doing better than you think. Keep practicing and it will feel easier every time. Thank you for learning with me, and I'll see you in the next Calm Math adventure. Bye!